This is Kasturi Day. Today I'm going to again discuss the light energy chapter according to ICSE syllabus class 8. Okay. So in my last video, I discussed about some spherical mirrors, concave and convex mirrors. Okay. Uh, that is their reflection. That's not refraction. Mirrors don't refract. They only reflect. Okay. So there's a mistake I want to rectify. And before that, I discussed about the dispersion of white light through a prism and how it is dispersed. It's explanation of the dispersion of the white light through a prism, equilateral prism. Okay. So I'm continuing with the related some related terms to of the spherical mirrors. Like first is focus. Okay. Focus is what? The rays of light which are falling on a spherical mirror and are parallel to the principal axis. See, these rays of light are falling on the spherical mirror and are parallel to the principal axis, get reflected by the mirror following the laws of reflection. That is, angle of incidence is equal to angle of reflection. So, following this laws of reflection, the rays of light which are falling on the spherical mirror, they are parallel to the principal axis. They get reflected by the mirror. Okay. Now, the normal at the point of incidence is obtained by joining this point to the center of curvature. The normal at the point of incidence where the light ray is striking the mirror, at that point, if a normal is drawn by joining this point to the center of curvature, okay, by drawing this point, the point of incidence is joined by to the center of curvature. If that is the normal. Okay. The reflected rays are not parallel to each other. The reflected rays are not parallel to each other, but they converge at a point in a concave mirror and diverge from a point in convex mirror. See, what happens when the light rays are falling on the spherical mirror, these light rays should be parallel to the principal axis. Okay. And after reflection, they either converge, that is, they meet at a point in a concave mirror, or they appear to diverge from a point in case of convex mirror. That is called the focus of the spherical mirror. Okay. Now, concave mirror, in case of concave mirror, the reflected rays meet at a point F, that is focus, capital F, on the principal axis, and this at which the light rays incident parallel to the principal axis meet, that is converge after reflection from the mirror. Okay. And convex mirror is the reflected rays appear to come from a point F on a principal axis behind the mirror. It comes behind the mirror. That is known as focus of the convex mirror. Okay. Therefore, focus of the mirror is a point of the principal axis at which the light rays are incident parallel to the principal axis appear to diverge after reflection from the mirror in case of concave mirror, convex mirror, and in case of concave mirror, they converge to a point. That is the focus of the concave mirror. Okay. That is represented by capital F, and the focus in concave mirror is real, and in case of convex mirror, that is focus is virtual. Okay. Next we come to focal length. Okay. Focal length. Focal length is the distance of focus from the pole of the mirror. That is represented by small f. Okay. Small letter f, that is focal length. See, from the picture you can see, in case of concave mirror, the focal length is inside the where this light rays are converging after reflection on the same side of the mirror. That is small f. Okay. Capital F is the place, that is the focus is the place where the light rays are converging. Pole is the center of the mirror, and C, that is the curvature, radius, it's a center of curvature. Okay. C is the center of curvature. Now in case of convex mirror, this focus comes behind the mirror, from which the light rays appear to diverge after reflection. Okay, and focal length is P, the distance between P and F. Okay, so it is denoted by small f. Okay, now focal length is equal to half of the radius of curvature, or you can say radius of curvature is equal to twice the focal length, 2 into focal length. Okay, next we come to rules for making ray diagram in a spherical mirror. What are the rules we need to follow to make the ray diagram? First is object is kept in front of the reflecting surface on its left side. So object has to be placed on the left side in front of the mirror. Okay. Object is kept on the principal axis. Object has to be placed on the principal axis such that it is perpendicular to the principal axis and its foot principal axis. Okay. So first one is that it should be placed on the left side in front of the mirror. It should be, second is it should be placed on the principal axis and in such a way that it is perpendicular to the principal axis and its foot touches the principal axis. Third is for constructing a ray diagram, we need to take at least two convenient rays whose path can be traced after reflection. Okay. Now, what are the convenient rays we are talking about? To construct the image of an object due to reflection by a spherical mirror, any two of the following three rays can be drawn. Now, what are the three convenient rays we are talking about? First one is a ray passing through the center of curvature. One is first, that is the ray passing through the center of curvature along its own path is reflected along its own path. That is the normal we are talking about, that if we are passing a ray from the center of curvature, it will come back to the center of curvature. That is the normal. Second is a ray parallel to the principal axis. Second is a ray which is parallel to the principal axis will come through the focus. Next, third is a ray passing through the focus. If a ray is allowed to pass through the focus, it will come parallel to the principal axis. So these three rays are convenient rays. You can take any two of them to construct a ray diagram for fulfilling the third option, third rule of the making a ray diagram. Okay. Next is see this first one. This first one is this, if it passes through the center of curvature, this will come back through the center of curvature. So this is the first convenient ray, second diagram, and then this is the second one. If a ray parallel to the principal axis comes back to the focus, or here it will appear to diverge from the focus. So this is the second convenient ray, and the third one is this one. If it is parallel, if it passes through the focus, it becomes parallel to the principal axis, or if we pass through the focus, appear to pass through focus, it will become parallel to the principal axis. So these are the three convenient rays we are talking about. Now, what is the difference between real image and virtual image? The real image is an image which is formed when reflected rays actually meet at a point. Okay. And virtual image is that in which the when the reflected rays meet on producing them backwards. Okay. Then real image is always inverted, whereas virtual image is erect and upright. Real image can be obtained on a screen, but virtual image cannot be obtained on a screen. Okay. See, for this, from this diagram, so the second one is a real image. So we get an inverted image, that is a real image. Okay. In the retina, the image formed in our eyes, it is formed an inverted image. It can be obtained on a screen. Okay, where here the actual the reflected rays actually meet. Okay, and in this case you can see this first one here. the reflected rays meet producing, when they are produced backward, then only they meet, okay, and it cannot be obtained on the screen, but they are erect and upright, okay. Next is that the images which are formed by the concave mirror. See, images which are formed by the concave mirror, first is at infinity, okay. When the position of the object is at infinity, the position of the image is at focus, okay, and the nature of the image is real, inverted, and diminished. Whereas when the position of the object is beyond the center of curvature, this beyond C, then position of the image is between focus F and C, that is curvature. Okay, nature of the image is real, inverted image, and smaller than the object. In case of the object, when it is placed at the center of curvature, image is also formed at the center of curvature, but it is real, inverted, and of the same size. When the image is, object is placed between C and F, that is radius of center of curvature and focus, then the image is formed beyond C, and the nature of the image is real, inverted, and bigger than the object. When the position of the object is at focus, the position of the image is at infinity, and here the nature of the image is real, inverted, but it is highly magnified. Okay, now position of the object, if it is between F and P, that is focus and pole, then the position of the image is beyond the mirror, that is behind the mirror, okay. And the nature of the image, it will be virtual, erect, and enlarged. See, from this pictures you can see the nature of the image, how it is formed and where it is formed, or where the object is placed at F, when the object is placed at C, when the object is placed at beyond C, then between C and F, object at F, and this will be the object at infinity, okay, and here this will be object at F, and this will be the object between pole and focus, okay. So please go through this. If you have any doubt, please let me know, and if you like this videos, please do press the like button, share with your friends so that they can also be benefited from these videos. And if you are a new viewer to my channel and not subscribed yet, please do subscribe to get the notification of my next video. And another announcement to make, that I'll be launching very soon a website which will contain many more subjects information, as even general knowledge also. So please do wait for that. And if you want to discuss any other subjects on YouTube, please let me know, and please do write in the comment box, okay. Thank you for watching it videos, okay. Thank you.